Colligative properties. Relative lowering of vapor pressure. Vapor pressure of solvent in a solution is less than that of pure solvent. When pure solvent is taken, it evaporates more from its surface, causes vapor pressure. When some solute is added to solvent, some of the surface area occupied by solute particles which do not evaporate. So the number of molecules evaporating decreases from solution. This will result in decrease in vapor pressure. The ratio of lowering of vapor pressure with the pressure of pure solvent is called relative lowering of vapor pressure. According to Raoult's law, relative lowering of vapor pressure is equal to mole fraction of solute. PS0 minus PS by PS0 is equal to XS. Hence, relative lowering of vapor pressure of solvent is a colligative property. Elevation of boiling point. We have learnt in Unit 5, Class 11, that the vapor pressure of a liquid increases with increase of temperature. It boils at the temperature at which its vapor pressure is equal to the atmospheric pressure. For example, water boils at 373.15 Kelvin, equivalent to 100 degrees centigrade, because at this temperature, the vapor pressure of water is 1.013 bar, 1 atmosphere. We have also learnt in the last section that vapor pressure of the solvent decreases in the presence of non-volatile solute. Depicts the variation of vapor pressure of the pure solvent and solution as a function of temperature. For example, the vapor pressure of an aqueous solution of a sucrose is less than 1.013 bar at 373.15 Kelvin. In order to make this solution boil, its vapor pressure must be increased to 1.013 bar at 373.15 Kelvin. In order to make this solution boil, its vapor pressure must be increased to 1.013 bar, the temperature above the boiling temperature of the pure solvent, water. Thus, the boiling point of a solution is always higher than that of the boiling point of the pure solvent in which the solution is prepared, as shown in figure. Similar to lowering of vapor pressure, the elevation of boiling point also depends on the number of solute molecules rather than their nature. A solution of 1 mole of sucrose in 1000 grams of water boils at 373.52 Kelvin at 1 atmospheric pressure. The vapor pressure of curve for solution lies below the curve for pure water. The diagram shows that delta Tb denotes the elevation of boiling point of a solvent solution. Let Tb0 be the boiling point of pure solvent and Tb be the boiling point of solution. The increase in the boiling point, delta Tb0, is equal to Tb minus Tb0, is known as elevation of boiling point. Experiments have shown that for dilute solutions, the elevation of boiling point delta Tb is directly proportional to the molar concentration of the solute in a solution. Thus, delta Tb is directly proportional to m, or delta Tb is equal to kbm. Here, m, molality, is the number of moles of a solute dissolved in 1 kg of solvent, and the constant of proportionality, Kb, is called boiling point elevation constant, or molar elevation constant, a biloscopic constant. The unit of Kb is kg mole inverse. If W2 gram of a solute of molar mass M2 is dissolved in W1 gram of solvent, then molality M of the solution is given by the expression M is equal to W2 by M2 by W1 by 1000 is equal to 1000 into W2 by M2 into W1. Substituting the value of molality in equation, we get delta Tb is equal to Kb into 1000 into W2 by M2 into W1. M2 is equal to 1000 into W2 into Kb by delta Tb into W1. Thus, in order to determine M2, molar mass of solute, known mass of solute in a known mass of the solvent, is taken, and delta Tb is determined experimentally for a known solvent whose Kb value is known.